Hey guys, I hope everybody's doing okay today. So I posted some notes online earlier today. Hopefully you had a chance to look at them. And this is your first introduction to factoring of quadratic expressions in this class. Okay, so this is going to be one of these essential skills, one of these foundational skills that you have to make sure you do well with, make sure you learn it, and you'll continue to build on the stuff that we start in this class for the rest of the classes that you'll have in high school. Okay, so you're going to be factoring in geometry, you're going to be factoring in algebra 2, and you're going to be factoring in whatever senior math class you take. Okay, now factoring is one of those words that, I don't know, it seems like we use it a lot. We use it for different things, but essentially factoring means you take something, a number, an expression, and you break it down into the product of other pieces. And a product just means you're multiplying those pieces together to get that original expression, that original number. Okay, so some examples that I put in here, and this is just something that you'll work with these trinomials more often. Okay, so when you see this example, the factored form of x squared plus 5x plus 6 is going to be x plus 2 times x plus 3. Now we're going to go into actually how we can come up with those actual factors, how we can come up with the factored form in a couple of days. Probably on Thursday we'll get into factoring trinomials. But it's going to use this box thing that we use to multiply with, and it's not bad. I know everybody can do it. But what we want to start with today is the other method that we use for factoring, and that's factoring by looking at the GCF. Okay, so to factor by GCF, we have to know what a GCF is. And let's go to the next page. Okay, we have to be able to find a GCF. Okay, so a GCF is the largest term, largest number, largest variable that you can divide out of a list of other terms. Okay, so if you have, a long polynomial, so we have this example on our notes of, what's that, 5x cubed minus 10x squared plus 25x. We want to factor it. Well, we'd factor it by finding the GCF. The GCF would be 5 times x, 5x. And the reason why that's a GCF is because that is the largest thing I can divide out of each one of the other terms. I can divide 5 from 5, I can divide 5 from 10, I can divide 5 from 25, and all the terms also contain an x. So 5x is the largest thing I can divide out of each term. Okay, it's the largest factor of each term. All right, now I put some examples down here at the bottom where we weren't actually told to factor. You just had to find what the GCF was between a couple of terms. Now on the next page I put some notes of how you can do that by just using the prime factorization of the terms. Write them out as a product of prime factors and write all the variables with powers out in expanded form. I just wanted to walk through one of these that same way, make sure that everyone is on the same page with it. So when we look at this example down here, we see what the answer is. The answer, the greatest common factor between these two terms, would be 2x squared. Okay, so how do we actually come up with that? Well, the technique I want to show you is just by writing out each term as the product of prime factors. So 2 times x cubed, 2x cubed. Now 2 is a prime number already, but x cubed, we can write that as x times x times x. So 2x cubed is the same as 2 times x times x times x. 6x squared. Okay, how can we write that? Well, 6 is not prime, it is 2 times 3. Then x squared is just x times x. So any of those parts that match will be part of the greatest common factor, will be part of the GCF. So the things that match, well, both of these have 2's, and both of these have a couple of x's. There's an x there, there's an x there, there's 2 x's right there. Okay, so we have to have the pieces matching in both of the expansions. So it looks like our GCF is 2 times x, or 2x squared. Okay, and that's all there is to finding a GCF. Now the numbers might be larger. Okay, on the next page, I believe, we have an example where we have 105x cubed and 21x squared. The numbers are larger, then do the prime factorization using one of those factor trees. And you see how it's worked out here. And I'm just going to let you go through that on your own and make sure that you can do that, finding the GCF. All right, now once you find the GCF, then to factor a GCF from an expression, all it takes is dividing that GCF from each term. Okay, now I showed a lot of work on the first one, but typically we're not going to show that much work for these. You'll get to a point where you can do a lot of the calculations or a lot of the arithmetic in your head. But the way I started this is I started with the original problem, 2x squared plus 6x, and I found the GCF. Now we did that previous, I believe. We said, well, we did one almost like this. But the GCF between these two terms, it wouldn't be 2x squared on this one, it would be just 2x. Okay, you can divide 2 from both of these terms. Both of them also contain an x. So 2x is my GCF. So what I do is I pull that GCF out in front of a group, and then inside this group, I'm going to write whatever's left when I divide 2x from each term. So if I divide 2x from 2x squared, if I divide 2x from 6x, okay, what's left over? And when I do that, let's see, 2x is still there, my GCF is still out front, and 2 divided by 2 is 1. Typically, we don't write a coefficient of 1. X squared divided by x. Okay, so when you divide a variable from a variable with a power, it's just like you're taking that many variables away from the original. So I'm going to take 1x away from x squared. This leaves an x. Okay, then I go to the next term. 6 divided by 2 is 3. And if I take x away from that term, I'm not going to be left with any x's. Okay, and the same thing's going to happen anytime you have the same variable with the same power on the top and bottom of these fractions, or you're dividing out something that's exactly the same. It's the original. Okay, those pieces cancel, and you're just left with 3 in this case. And that's my factored form of the original expression. Now you can always check these answers. Okay, all you have to do to check them is use photomath. No, you don't use photomath. Yeah, you can use photomath to check them, but you can just distribute these things, and it should end up back at the original problem whenever you distribute, and that's how you can check your answers. Okay, so 2x times x is 2x squared, which that was the original first term. 2x times 3 is 6x, and that was the original second term. So yeah, it looks like we did that one correct. Okay, so I've got some practice on here. I got the answers to the practice as well, but don't skip ahead to the last page before you work through some of these problems. Now, if you work through all of them, then you can fill the answers from the choices down here. You fill those in down here at the bottom, you get the answers to these riddles. What do you get when you cross a chicken with a centipede? What do you get when you cross a mink with an octopus? I don't know. But, actually I do know, I just don't want to tell you. But I wanted to go through a couple of these problems with you. Make sure that you were okay with them. If you have any issues, please ask me a question, send me an email. We are going to have Google Meets tomorrow, so yay for that. We'll be able to meet in person, and I'll be able to go over difference of squares with you. But let's just jump into these. Let's do a couple of them. I'll just pick a few random ones like 3, and let's say 3 and 6. And let's see, on the other side, let's do something like, say 10 and 10, 12, let's do 14. All right, so we got 4 problems that we're going to work through and make sure that we can do them. Okay, so I'm going to have to start up here at the top so I have enough room, but I'll start with number 3. And number 3, original 14x cubed minus 7x squared minus 35x. All right, so first we identify what the GCF is. Okay, so what is the largest thing I can divide from 14, from 7, and from 35? And, well, 7 is a prime number, so the only thing I can divide from prime numbers are 1 and that number itself. So my GCF is either going to be 1 or it's going to be 7. Or it's going to be part of the GCF. And it's 7. I can divide 7 from 14. I can divide 7 from 35. So 7 is part of my GCF. Okay, next I want to look at the variables. Okay, and I notice that each term contains an x. So x is going to be part of the GCF. X to the first power is the lowest power of x. Okay, so I can divide 7x from all the terms, no problem. And that is my final GCF. Okay, so now I need to divide that 7x from each term. Okay, and I'll set it up like this. I'll take this first term, divide it by 7x, divide that guy by 7x, divide that guy by 7x. I'm going to put the result inside these parentheses, and then I'll be done. Okay, so this first one, 14 divided by 7 is 2. X cubed divided by x squared is just, or x cubed divided by x is x squared. Go to the next term. We have negative 7 divided by positive 7. It's a negative 1. Typically, we don't write a 1 as a coefficient. But x squared over x. Okay, just taking an x away from x squared, it's going to leave us just 1x. The last term, negative 35 divided by 7 is negative 5. And the x's, same top and bottom, so they kind of cancel out. And that is my factored form. 7x times 2x squared minus x minus 5. And when we look over here to the right, notice that there's 2 letters that have GCF of 7x. Be careful, there's a few of these like that. And there's only one right answer though, and it's O. Okay, so 3 is an O, and I'll go ahead and put an O everywhere where I see a 3. O, O, maybe that's it. All right, so the next one, number 6. Okay, so number 6, let's see, we have some terms like 3x with a power of 4. We have a 12x with a power of 2 and minus 33. Okay, so first GCF. Well, 3 is a prime number, so the GCF has to, the coefficient has to be 1 or 3 again. And it is 3. 3 divides into all these numbers. So 3 is part of my GCF. And let's see, the terms, they don't all contain an x. Okay, so there's no variable part of this particular GCF. 33 is just a constant, it's 33. So the only thing you can have as a GCF is a number, because remember, we have to be able to divide that GCF from each one of the terms. Okay, so I'm going to divide all of them by just 3, and that should give me the correct answer. Okay, so 3x to the 4th over 3. Well, let's see, it's just going to leave us next to the 4th. 12 divided by 3 is 4, and the x's don't get touched. Negative 33 divided by 3 is negative 11, and that's done. So when I look over at the right, let's see, it's either L or I, but I is the only one that matches. So everywhere I see a 6, I'm going to put in I. So that means an I goes here. That means an I goes nowhere else, I guess. Okay, now the ones on the right-hand side. We have 10 and 14. So I'll just come down here to the bottom. Number 10, let's see, had a whole bunch of variables. We have 3a squared b squared. And we have 15a b cubed. All right, so first, the coefficient, the number part of the GCF, okay, that's going to be whatever the largest thing I can divide out of 3 and 15. So out of 3 and 15, well, the largest thing I can divide out of those is 3. Now variables. If you have any variables that are common, any variables that match between the terms, they will be part of the GCF. Both of these terms contain an a. And just an a to the first power is the lowest power of a. So that's the largest a I can divide out of everything. B's, both of these contain a b. the lowest power of b is b squared, so b squared is going to be part of my GCF because I can divide b squared from both terms. So we can accomplish this by just dividing each term by the 3ab squared and see what's left over. So when I divide the first one by 3ab squared, well, 3 divided by 3 is 1. A squared divided by a just leaves us 1a. And b squared divided by b squared, that's going to cancel. So we're just left with a. Go to the next term, do the same thing. 15 divided by 3 is 5. A divided by a, they cancel. B cubed divided by b squared, so that means we're going to take 2 b's away from b cubed, which leaves us just b. And that's my factored form. 3ab squared times a plus 5b, which hopefully that matches with one of my pieces. And I'm not seeing it. And not seeing it. It's got to be there somewhere. Oh, wait, there it is. Letter M. Letter M. So where I see a 10, I can replace that with an M. 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 And yeah, that's it. Okay, now 14. Same process. I'm not going to write the problem down. Well, I guess I will. 24 ab to the 4th. We have 12 ab cubed. We have negative 18 ab squared. All right, so numerical coefficient part. What can I divide out of 24 and 12 and 18? Can I divide 12 out of all of them? No, I can't divide 12 from 18. But what can I divide out of 18 and 12? Let's see, 9. No, can't divide 9 from 12. Oh, 6. I can divide 6 from 24, divide 6 from 12, divide 6 from 18. So that's part of my GCF. Now the variables. Looks like we have an a in all those, and actually we have an a to the power of 1, a to the first power in all of those terms. So a is definitely part of my GCF. And then we have b's in all of them. They have different powers on them though. We want to get the lowest power of b, which is power of 2, b squared. That's part of my GCF. So we should be able to divide that 6ab squared from each one of the terms. And let's see, 24 divided by 6 is 4. Take an a away, take 2 b's away, so we have 4b squared. Yeah, you go to the next term, do the same thing. 12 divided by 6 is 2. A's, take an a away, they're gone. Take 2 b's away from b cubed, you're left with b to the first. The last one, negative 18 divided by 6 is negative 3. The a's cancel, the b squareds cancel, so that looks like we're done. So we have 6ab squared times 4b squared plus 2b minus 3, which that looks like it matches up pretty good with r. So everywhere where I see a 14, I can replace it with an r. R. And r right here. And see, oh, one more r. So yeah, that's it. That's all of them. All right, so see if you can get the rest of these figured out. And if you have any problems, shoot me an email. Like I said, we will have a Google Meet session tomorrow, and I'll go over this again if anybody has any questions. And we'll start factoring difference of squares. That was easy. And then Thursday, we're going to start factoring trinomials. Friday, we'll probably have a little assessment, little quiz that is going to test you on the factoring part of this. All right, guys, so y'all stay safe, and I will see you tomorrow.